Good morning. It is Wednesday, December 2nd, and you are here in chemistry ready to rock and roll on covalent bonding. We ended on Monday talking about Lewis dot diagrams and ionic bonding, and I want to do a quick review of some of those, some of that information just before we get into covalent bonding so you can start to see like what's the real difference between the two. The foundation, though, for both of them is that atoms are most stable when they have a full outer shell of electrons. For most atoms, that's going to mean that they want 8 valence electrons. We call having 8 valence electrons an octet. What's new and different for you today, though, is that hydrogen is an exception to that rule. Hydrogen is itty bitty. It's the smallest atom on the periodic table. It has 1 energy level. It literally can only fit 2 valence electrons on its energy level. So hydrogen, it only wants 2. Instead of calling it an octet, we call it a duet. All right. So you think of like singers singing a duet. There's only 2 singers when they do that. Hydrogen wants a duet. It only wants 2 valence electrons. So that's the foundation for both ionic and covalent bonding. A review of ionic bonding, though. We talked a lot about this on Monday. We did lots of practice problems. Ionic bonding is where we transfer electrons from one atom to another atom. The metals are the ones that typically give up their electrons and they become positively charged cations. They give their electrons to a nonmetal, which will become a negatively charged anion. Because they become oppositely charged, they're then attracted to each other. We form this ionic bond. So one of the go-to examples when people are like, can you give an example of an ionic bond? You would say table salt, sodium chloride. Sodium is your metal, gives up its electron to chlorine, your nonmetal. They become ionically bonded. I found these cartoons off of like Khan Academy, and I think they do a really great job of showing what ionic bonding is. So here we've got like 2 homegirls. One of them is like, for some reason, wearing a blanket, but she's like, I'm sweating so much. I wish I could just give this blanket away. And then like other homegirls like, I am so cold. I wish I could have a blanket. And so first homegirl is like, well, then here, like take the blanket. And then they're both happy, right? The girl who was once hot is no longer hot, and the other girl who was cold is now warm, right? So this is an example of what ionic bonding is. One atom wants to give away its 1 valence electron, so it ends up having an octet. The other one just needs 1 more valence electron so that it has its octet, so they just do that. They transfer from one atom to another, and then they're all stable. So that's ionic bonding. Now here's a cartoon that's going to show you what covalent bonding is. Same 2 girls, but they're both cold. They both need a blanket. Well, the solution to the problem, they share the blanket and they both end up getting warm and comfy and it's good, right? Covalent bonding is just like that. Covalent bonding is the sharing of electrons between atoms so that both of the atoms can have an octet. This always happens between 2 non-metal atoms. So we're looking at atoms that are on the right-hand side of the periodic table. Atoms like carbon and sulfur and oxygen and silicon and hydrogen is going to be involved because remember, hydrogen is technically a non-metal. Elements like that. Take a look at this example here. This is a water molecule. Notice we've got our 1 oxygen as our like middle central atom. We've got a couple hydrogens on either side. We use lines to represent covalent bonds. So you see how there's this line right here between hydrogen and oxygen. That just means that hydrogen and oxygen are sharing their electrons with each other. So hydrogen, remember hydrogen wants a duet. Hydrogen has its own electron and is sharing 1 electron with oxygen. So hydrogen has a duet. Same for the other side, hydrogen. It is sharing with oxygen. So this hydrogen also has a duet. Oxygen in the middle is an element that wants 8 valence electrons. And so if we count them, 1, 2, 3, 4, 5, 6, well, plus the 2 that it's sharing though from hydrogen, 7, 8, oxygen now has an octet. So it's all good, right? So those lines represent covalent bonds. 1 line represents 2 electrons, or we say My brain just like frazzled right there. One line represents 2 electrons, or we say it's a pair of shared electrons. Man, let me take a sip of coffee, yo, and then let's move on. So, more examples. Here we have, I believe this is ammonia. It's nitrogen with 3 hydrogens. Notice on the far left side, these are the Lewis dot diagrams for each of those elements, right? We know hydrogen wants 2 valence electrons. Nitrogen needs 3 of them, so they're going to form covalent bonds with each other. So that way when they share, everyone ends up having the octet or the duet that they need to be stable. Same thing for down below. This is methane gas. Whenever I think of methane gas, I think of this article that I read about Michigan State farmers trying to harvest methane gas being produced from the stomachs of cows as a form of renewable energy. Michigan State, man, they come up with the wildest things. Anyways, methane gas, carbon, 4 valence electrons. It needs 4 more in order to be stable, so it's going to share with 4 hydrogen atoms. They form covalent bonds, and then everyone has their octet or duet that they need to be stable. Now, that's just like the overview, right? We're talking about covalent bonding. We're talking about sharing of electrons. We've seen that we use lines to represent them, and let's kind of get into the more nitty-gritty details of covalent bonding. One of the nitty-gritty details is that we're not just limited to sharing 1 pair of electrons at a time. If we do share 1 pair of electrons, we call that a single bond. And it's a relatively strong bond. Like you can see it here in hydrogen and chlorine, they're sharing 1 pair of electrons. It's a single bond. But if you have atoms that need to share multiple pairs, take a look at what that looks like. For example, in carbon dioxide, carbon is going to share 2 pairs of electrons with oxygen. And notice there's 2 lines here. We call this a double bond. So this double bond is a little bit stronger than this single bond from hydrogen and chlorine. If we looked at the next one, 3 pairs of shared electrons, like between 2 nitrogen atoms, that would form what's called a triple bond. So 6 total electrons are being shared, or we say 3 pairs of electrons, right? That's the strongest bond out of all of these. Now, I will say majority of the time you're going to be dealing with single bonds. You might be in scenarios where you'll have to create double bonds with atoms. Rarely will we probably do problems that involve triple bonds. So lucky you. But when you get to college, that's a whole different thing. Okay, so let's get into the second nitty-gritty detail. How do we actually draw covalent bonds? Here's the steps. I think there's 5 of them. If you ask someone else, they might say there's more, but this is how I think of these problems. The first step that we want to think about is what is the total number of valence electrons that we're possibly dealing with in a molecule. So if we were looking at the molecule of methane gas, those cows, methane gas, CH4, we know that carbon is from group 14, so it has 4 valence electrons. Hydrogen is group 1, so it has 1 valence electron, but the subscript 4 here tells us that we have 4 hydrogen atoms, so we multiply it by 4. In total, that means that we have 8 valence electrons that we need to figure out where they're being placed, whether they're in bonds or whether they're just left with single atoms. Part 2, determine the central atom. That just means what is the atom that's going to be at the center of your molecule. It's pretty easy to figure out who the central atom is going to be simply because they're the only one of its kind out of a molecule. So if we're looking at methane gas, CH4, the only atom that's like of its own kind is carbon. Otherwise, there's 4 hydrogens, right? So carbon is our central atom. We would draw carbon first, and then we would draw hydrogens surrounding carbon. Step 3, draw single bonds that connect every atom together. All right, so we would go through and we would draw from hydrogen to carbon all the way around. Then we would double check our valence electrons. So we'd say, okay, how many electrons have we already drawn? We'd say, okay, there's 2, 4, 6, 8, and I had 8 total valence electrons that I needed to place. So that's all I have to do with that molecule. I don't have to add any dots to represent other valence electrons I don't have bonded yet. So the last step, really kind of sometimes, is to double check that all the atoms have octets or duets that they really need. So if we look at hydrogen, does hydrogen have the duet that it needs to be stable? Well, if we look at the bond here, there's 2 electrons in that bond, right? So this hydrogen is stable. This hydrogen has the 2 electrons in this bond, so it's stable. This hydrogen has the 2 electrons in this bond, so and the same for that one, right? Then we look at carbon. Carbon wants an octet, so it needs 8 valence electrons. Look at the bonds that carbon has formed. It is sharing 2, 4, 6, 8 valence electrons, so this carbon is also stable. Has its octet, it's good. The last step would be to turn pairs of valence electrons into double or triple bonds if needed. Like if you have an atom that doesn't have an octet yet, and you're saying, it needs to keep sharing with other atoms, then you'd start forming those double or triple bonds. Like I said, most of the time you're going to be dealing with single bonds. You might have a few instances of double bonds. Rarely will you have triple bonds. I'm going to leave this here in this video. Now your job is to go watch. I have 2 other videos that you should watch to help you fill out some of the problems from the Jamboard. I had a technology snafu in the middle of one of them. That's why there's 2 videos. But definitely, oh my gosh, I cannot push you enough to go and watch those videos to help you, because covalent bonding is the trickier of the 2, ionic versus covalent. Covalent is tricky. Taking a look at the Jamboard. So this first problem, CH4, technically I kind of talked you through it right here. So you can just kind of copy paste a little bit. When we're looking at the Lewis dot structure, one of each element, what we're looking for is what would be the Lewis dot structure that shows the bond between carbon and one of the hydrogens. So if I was to draw that, I guess the pen works well. So here's carbon. I know that carbon has 4 valence electrons, right? So there's 1, 2, 3, and 4. I know that hydrogen has 1 valence electron. Bloop. And then the bond that would form is a pair of electrons that are being shared, right? So I would either just draw a line through them like that, or you could circle them, whatever floats your boat. And there's that bond that's formed, that covalent bond that's formed between carbon and hydrogen. Now, your final model with all of the bonds and stuff, that would be the model that looks like here's carbon that's single bonded to a hydrogen. I feel like I'm rattling on and on. I hope not. Sorry, you guys. Covalent bonding is kind of hectic. I'm not going to lie. It gets kind of crazy. But like I said, watch the videos. I do the hardest problems in the videos, and then you guys get all the easy ones. So maybe that helps. Okay, so that's kind of the final answer that we're looking for when you go through these problems. I think there's 12 problems. I put stars next to the ones that I am going to do. So you can kind of copy paste from those videos. Otherwise, be prepared with these completed in the afternoon time to share with your groups, and then be prepared to share out a couple answers to the whole class. If you have questions, do not hesitate to email me. Like I said, this is the harder of the 2, so don't feel like you need to understand it the first time around. It's okay to ask questions. Let me know what you guys need. I'm here to support you.